Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We are moving into Chapter 2, which is linear equations and functions. So today's lesson 2.1 is called functions, and we have these essential questions. We have be able to determine if a relation is a function, be able to give the domain and range of a function or a relation, be able to use the vertical line test to decide if a relation is a function, and be able to use the function notation to name functions, be able to evaluate a function for a given value, and be able to graph a linear function. So functions are a type of relation, and a relation is a mapping or pairing of input of what? Input values with output values. With what? With output values. Okay? So domain are input values, and ranges are output values. Okay? So we have this input and output table over here with these little circles, and we have arrows. So basically this is saying 3 is matched with -4, -1 is matched with -4, and -7, or just 7, and 2 is matched with 7. Okay? So basically it's just saying those are matching that way. So a relation, I'm going to zoom in a little bit so I can write this here, is a mapping or pairing, dang it, of input with output values. Zoom out so you guys can read that and write that down. A mapping or pairing of input values with output values. Okay? Domain is the input values, range is the output values. So what numbers do we have? So this is going to be our inputs. What are our inputs for this relation we have here, for example, 1? Well, we got 3, we got 1, and we got 2. You could also put them in order for from smallest to biggest. I like to put them in the exact order that they show up on the actual relation, but either way is fine. And our outputs is our range. So what are our outputs? Well, we have -4 and 7. Easy peasy. All right. It says a function, though, is a mapping where each input, each input has exactly one output value, okay? So example 2 says, is the mapping in example 1 a function? Well, let's look at this here. So we have our input values, we have our output values, right? Here and here. So what it's saying, if this is going to be a function, it means that each input does not repeat or go to two different output values, okay? Each input has exactly one output value. Let's look at 3 first. Well, 3 just goes to -4, so that's 1 to 1, that's good. But you see here, we have 1 goes to -4, and 1 goes to 7. Does that one input, which is 1, have one output, or does it have 2 outputs? It has 2 outputs. This one is not going to be a function. 2 does go 1 to 1 from 2 to 7, which is fine. But this is going to be no, because 1 has 2 different outputs. 1 has 2 different outputs. And that's a problem. That's what makes something not a function, when you have an input going to 2 different outputs. Okay? And then we have this set functions, the set here. It's saying 2, 3, 3, 3, 5, 6, and -3, 0, a function. If you want, you can write them vertically like this: 2, 3, 5, -3, and then we have 3, 3, 6. Sorry, 6 and 0. So for this one, does each input have exactly one output? Well, let's look at this. 2 goes to 3, that's fine. 3 goes to 3, that's fine. 5 goes to 6, that's fine. -3 goes to 0, that's fine. You may have seen these repeating 3s and thought, oh, that's not going to work. But you could actually have a function like this: 1, 2, 3, 4, and 5, 5, 5, 5. It does not say anything about repeating output values. That's fine. You just can't have repeating input values. Oops. you can't have repeating input values like 1, 1, 2, 3 going to do two different numbers here. One go to 4, one go to 6, okay? This is going to be a problem when you have repeating inputs going to different outputs, okay? But there's nothing that says that you can't have repeating outputs, like, you know, the different inputs going to two different outputs. So this one's going to be fine. This one's going to be yes. And the reason is no repeating inputs. Oops, that was a bad W. With different outputs. No repeating inputs with different outputs. Okay. All right, that's all that makes something a function is no repeating inputs going to different outputs. All right, linear function in the form y equals mx plus b. You guys may have heard that before. That is called what form? Do you guys know what form that's called? We had standard form, point slope form, slope intercept form. This is slope intercept form actually because we have a slope and we have an intercept. This is going to graph a line. All right, I forgot to write down some examples. That would be like y equals negative 2x plus 4 or y equals 1/3 x minus 7. Those are examples of lines. Okay? The coordinate plane, we have Roman numerals to remember the coordinate plane. See if you remember which ones go where. It's 1, 2, 3, 4. Which one starts with 1? It's going to be the top right is our 1. Now we're going to go this way or we're going to go this way. Which way is the next, which one's 2? The left is 2. Down here is 3. And down here is 4. 1, 2, 3, 4. Those are the coordinate planes in the 4 quadrants. Okay? All right. This is hopefully was a little bit of review of some of this stuff. Okay, graph the relation. Decide whether the relation is a function. Okay, so we're going to graph 2, 3. So we're graphing points on a line. So we need to go left or right for x and then up or down for y. So if we have a positive 2 for x, we're going to go left 2 or right 2. We're going to go right 2. And if we have a positive 3, we're going to go up 3 or down 3. We're going to go up 3. Right? Because, so for x, positives to the right, negatives to the left. Oops, that was bad. And for y, positive is up and negative is down. Okay, that's just a little refresher for that. Cool. So we graphed those. We got 2 negative. Wait, what did I do there? Something's goofy. That doesn't need to be there. So we went right 2, up 3. Now we have 2 negative 1s. That's going to be positive 2. We're going to go right 2, and then we're going to go down 1. 3, 0. Going to go right 3. What does 0 mean? 0 means don't go up or down or left or right at all. It means stay. So we're going to go right 3, and then we're going to stay on the x-axis. If it were 0, 3, we would go left or right. We wouldn't go left or right at all. We would go up 3, and that'd be 0, 3. Be careful with those. Don't mix those up. Do exactly what it says. X is left or right, so we're going to go right 3, and we're not going to go up or down at all with the y equals 0. All right, now we got 1, 2. 1, 2. Positive 1, right 1, up 2. And there's our points. Okay, now here's a trick. When you have a graph, you can tell instead of looking at the actual table. Do you guys think this is a function from the table? Yes or no? What do you guys think? This one's not going to be a function because we have 2 goes to 3 and 2 goes to negative 1, and that's a problem. We can't have repeating inputs going to different outputs. But you can also tell from a graph. And the way you tell from a graph is called the vertical line test. And the vertical line test works like this. A relation is a function, what? If no vertical line intersects the graph at more than 1 point. At more than how many points? More than 1 point. So I should be able to take my pencil across my paper and draw a vertical line straight up and straight down and see it should only cross the points once. Oops. So do you guys see if we draw a vertical line like this, you see how it crosses here and here? That is a problem. So you want to draw your line strategically to see if there's any points where it's going to overlap vertically up and down when you draw a vertical line. It's not a horizontal line test. It's not going to be like this. That doesn't matter. Left and right doesn't matter. It's only up and down, but this one is not going to be a function because it crosses 2 points when you draw a vertical line on this graph strategically, okay? All right, example 5 and 6, or example 5. Which of these is a function, which of them is not, left or right? Well, let's draw some vertical lines here just for funsies. There's 1. There's 2. See how we got, this crosses once, this one crosses once. This one's going to be yes, because it only crosses once on that graph. If you draw it horizontally, it's going to cross more than once, but it's not a horizontal line test. It's only a vertical line test, so horizontal doesn't matter. What about the second one? Let's draw a line here. Well, you can see it crosses right here, and it crosses down here. It crosses twice. Same thing over here. Crosses once here, and crosses once here. So this is going to be no, because it crosses more than once vertically. Crosses the graph. The graph is this right here. Right? Okay, easy as that. All right, moving along. Function notation. So, we had y equals mx plus b, which is a linear function. And we have function notation is this, f of x equals mx plus b. It's not f times x, it's f of x, which we'll talk about in a second here. But this is called function notation. Okay? And so basically it's just a fancy way to replace y to make it a little bit easier to work with some harder kind of equations and harder kind of functions, I guess. So this is read as the value of f at x, or simply f of x. Okay, so basically f is the name of the function and x is what we're going to plug in stuff for x. So if we're looking for f of 4, you'd plug in 4 for x and see what your answer gives for an answer, okay? So instead of using y, because if you have two equations, you have y equals 2x minus 4 and y equals 1/3 x minus 7, like that, you can't call these both y. You're going to get confused because they're if you call them both y, you're not going to know which one you're talking about. But what you could do is you could replace this, you could call this g of x and f of x, and then just replace it with different letters, and that's going to make it easier to know which one you're talking about. Okay? All right, cool. So let's go ahead and do example 6. Evaluate each function for the given values. We have f of x equals 5x plus 7 for x equals 4. All right. Well, we're going to take this 4. We're going to plug it in for x here. And the way I'm going to fix that, when I'm checking when x equals 4, it doesn't become f of x anymore. It becomes f of 4 equals 5 times 4 plus 7. We're checking the function value at x equals 4. We replace the x with a 4 when we're doing that. Okay? So now we have f of 4, not f times 4, f of 4, the function value at 4. What's 5 times 4 going to be? It's going to be 20 plus 7. So f of 4 is going to equal, what's 20 plus 7 going to be? That's going to be 27. So that is the function value. That would be y equals, if you did the same thing, you did y equals 5 times 4 plus 7, you would know that y equals 27. It's the same thing, except this one's more specific by saying what value x is going to be with the f value, okay? All right, cool. All right, so graphing a function. Graphing a function, a graph is a collection of all points x, y whose coordinates are solutions, of the equation. Okay? Collection of all points x, y whose coordinates are solutions of the equation, basically. So when you graph points and they make a straight line, everything on the line is going to be a solution because it would satisfy the equation here. So we're going to check the points -1, 0, and 1. Okay, so to find a solution, all you got to do is take this number and plug it in for x and then solve for it, and that will give you a solution, right? So let's go ahead and do that. So we're going to do y equals, we're going to plug in -1 in for x, we're going to plug in, oops, lots of mistakes here. 0 in for x, we're going to plug in y equals 1 in for x. Okay, so I'm taking these values, I'm plugging them in for x right here, and right here. That's the second one, and here's the third one. Okay, so let's solve this now. So we got y equals, what's negative 2 times negative 1 going to be? Remember, we do PEMDAS. We don't do plus 1 first, we do multiplication first. Negative 2 times negative 1 is 2, plus 1. So y is going to equal 3, so we get 3 for negative 1 as a solution. Okay. Negative 2 times 0 is what? It is 0 plus 1. 0 plus 1 is 1. So this is going to be 1. And y is going to equal, we got negative 2 times 1, which is going to be negative 2 plus 1. And negative 2 plus 1 is going to be negative 1. Okay, so let's graph these. We got negative 1, 3. So we're going to go left 1 up 3. Negative 1 tells us to go left 1. 3 tells us to go up 3. 0, 1, is it right 1 or is it up 1? Well, it's 0. It means don't go left or right at all. It means stay. And then we're going to go up 1. Okay, be careful with your graphing with that. 1, negative 1. Right 1, down 1. Positive 1, negative 1. And we're going to graph a line here. And there's your line. So that's how you find solutions. So test something that's not a solution. Let's test the point, I don't know. Let's test the point 2, 0. So I plug in, if I'm testing 2, 0, which is my x and y, let's plug in 0 for y equals 2, negative 2 times 2 plus 1. So 0 equals negative 4 plus 1, and 0 equals negative 3. You see how that doesn't work? So basically the line, the graph is going to be the collection of all solutions, and the way you find, if you plug in solutions by plugging them in for x and solving for y, you're going to get all these points that are on the line like this, okay? Whereas if you find a point like 2, 0, which is off the line, that's not going to give you a true result, and it's not going to give you the answer, okay? All right, cool. That should be it for this lesson. Thanks for watching. Take good notes and do your homework, and we will talk soon.